Hello, and welcome to another video in the Designing on Particle series, where we walk through best practices and recommendations as you are building your particle-based products. My name is Eric Fosnacht, a solutions architect here at Particle, and in this video we will explore ways to debug your particle-powered application, specifically focusing on using the Particle Debugger. Now, if you haven't already watched the previous series videos, please do so as these videos build on each other. As we go through the video today, we will be reviewing and debugging an application that uses our Asset OTA feature. As applications become more and more complex, they may require the use of additional connected devices for more edge computing. But how do you update these devices? Asset OTA can not only update the particle device, you can also update the connected peripheral devices as well. And in this application, we will use it to update the firmware on an Arduino Uno. While this application utilizes Asset OTA, we won't dive into its implementation. We will rather use it as a sample application to guide us through debugging techniques, which you can then later apply to your more complex applications. Today, we will discuss the basics of debugging, how to set up the Particle Debugger and the hardware, start a live debugging session in Workbench, and lastly, we will discuss some best practices and tips for effective debugging. So let's get started. Let's start with the basics of debugging. Specifically, why is debugging crucial? IoT applications are becoming ever more complex. And although by using particle devices, we handle much of this complexity, you can run into some common issues like your particle device is not coming online, particle function primitives aren't being triggered as expected, and data inside of a particle publish is incorrect. And when issues do arise, where do you begin? This is why debugging is crucial, as it gives you insight into the root cause, which in turn creates higher quality control. There are three common ways to start debugging your application. First is serial printf or printf debugging, and this is the most popular way many start debugging. This will print messages to the USB port that can be captured with a terminal program. However, instead of using serial printf, we recommend using the logging class. It works just like serial printf, except you can manage message levels and segregate messages appropriately. And the best part is it's already built into DeviceOS, and we already reviewed how to implement in the Healthy Design Principles video. The last common debug method is using the Particle Debugger. This is the most powerful method as it allows you to use step-through debugging by setting breakpoints, inspecting and watching variables at runtime, and even navigating the call stack. In this video, we'll concentrate on using the Particle Debugger and how it enables users to conduct step-through debugging, thorough analysis, and troubleshooting of their application. Next, let's learn how to set up the Particle Debugger and the hardware. The first step in setting up the Particle Debugger is to ensure the firmware is the latest version. To do so, navigate to the debugger drive that is enumerated on your computer, and in the drive there should be a file, details.txt. In that text file, you should see a line with the interface version. This should be 0254.2. If you have an earlier version, or if your debugger doesn't enumerate as a DAP link drive, we recommend updating the debugger firmware. To update the firmware, download the latest version from our debugger docs page. While plugging in the USB, hold the button down. The device should enumerate as maintenance if done properly. Then just drag and drop the downloaded firmware onto the drive. And note, it is normal if your operating system warns that the disk was not ejected safely. Once you confirm your debugger is running the latest version of firmware, the next step is to connect the debugger to the particle device. For the hardware setup, it's slightly different depending on the generation of platform you are debugging. For Generation 3 and 4 devices, use the supplied ribbon cable and plug it into the SWD connector on the debugger and the platform. For Generation 2 devices, use the female header and plug directly into the platform. Then just plug the debugger into an available USB port and you should be up and running. Also, we typically recommend that you put the particle device into DFU mode before starting a debugging session, as it creates a known starting point for flashing firmware. It's that simple, and your particle device and debugger are now set up to start a debugging session. Now, in this example application using Asset OTA, I have noticed that once the OTA is initiated from the cloud, the particle device gets stuck in a loop, continuing to update the Arduino Uno. So to identify the root cause, let's start an actual debugging session in Workbench, walk through some key features of the debugger, and debug the application. Here we have our Asset OTA application, and we want to start debugging. To start a debug session, click on the Run and Debug icon to open the debug sidebar. Then you want to make sure that the Particle Debugger is selected. Finally, make sure the particle device is already in DFU mode and press the Run button. If prompted to compile DeviceOS locally, please do so and press Compile now. Note that this may take a few minutes as the compiler will build all of DeviceOS. This long compile time should only occur on the first compile, and the subsequent compiles should take much less time. Once the compile completes, press the Run button again and the debug firmware will be flashed to the particle device, and the debug session will be started. Once a debugging session is started, the process is halted on the attach, and you will need to continue the process to actually run the application firmware. However, before we actually continue with running the firmware, this gives us a great opportunity to set breakpoints. To set a breakpoint, all you need to do is press to the left of the line number you want to break on. Because we are trying to identify the root cause around the Asset OTA getting stuck, let's set a breakpoint in the loop function, specifically on the logic around Asset OTA. Alternatively, you can set the debugger to break on a function using the plus button in the breakpoints panel, and then enter the name of the function. For our case, we'll want to break on the raise trigger function that initiates the Asset OTA. Now, once we have a breakpoint set, we will want to continue. When the session was started, a panel of debug actions appeared at the top of the screen, and we'll want to press the continue button. Now, the application will run as expected until the breakpoint is hit. As you can see here, the application was halted on the line where we put our breakpoint, and you can now start debugging your application from this point on. So now that we have a breakpoint set, we have various options to step through our code using the Debug Actions panel. In order from left to right, we have Reset Device, which resets the particle device. Continue, which will allow the application to continue until another breakpoint is hit. Step Over, which will move the execution to the next line and pause again. This is handy when inspecting variables, calling the stack, and more. You also have Step Into and Step Out, which if the current line is a function, you can step into and out of a function. A good example of using this is if you want to investigate the Asset OTA function and inspect the source. And note that you can even step into DeviceOS and library functions as well. Restart, which will restart the debugging session. Note if you want to do this, make sure you put the particle device into DFU mode before selecting this action. And disconnect, which disconnects the debugger and ends the session. The main actions I use are continue, step over, step in and out, and disconnect, with continue being by far the most common action out of the bunch. A couple more tools that we can leverage when debugging applications is inspecting and watching variables, along with monitoring the call stack. These panes allow you to monitor various data fields, including variables, which can be super handy while troubleshooting. For our case, let's watch the update trigger variable to make sure the Boolean value is set when an OTA is initiated, and also ensure it is reset once complete. Now, before we actually start troubleshooting, I want to note that our current breakpoint in the loop function is blocking the cellular connection. So in order to actually initiate an OTA from the cloud using the particle function primitive, we need to remove the breakpoint. And then we will rely on the breakpoint set on the raise trigger function to start troubleshooting. Here we already have the breakpoint set on the raise trigger function, halting our application. Now we want to add our breakpoint back into the loop function to step through our asset OTA logic. We can add it back in since we don't require cellular connection to step through the OTA logic since the cloud function was already initiated. Let's continue and hit the new breakpoint. Here you can see that the update trigger variable is now set to true. And we want to continue, complete the OTA, and then have the application run until the next breakpoint is hit. Bingo! I think I identified why the asset OTA would continue to update and get stuck in the OTA loop. Luckily, we were watching the update trigger variable as based off this, I failed to reset the update trigger value after the Arduino was updated. To confirm, let's continue again, and I bet the value will remain true. Dang, I thought I had this working, but at least I think the fix is as easy as adding a line of code after the update to reset the Boolean value. Fingers crossed that fixes it. So let's restart the debugging application to see if this fixes the issue. Before we restart, let's remove our breakpoint in the loop function. And we also need to put the BSOM device into DFU mode. I went ahead, restarted the debugging session with the fixed flash to the BSOM device, and have the application halted on our breakpoint set on the raise trigger function. Let's add our breakpoint back into the loop function to step through our asset OTA logic, and then let's continue to the new breakpoint. As we saw already, the update trigger value is correctly set to true. And now let's complete the OTA and see if the trigger value resets. Perfect. Here you can see the variables now correctly reset. And to confirm we don't enter another OTA, let's add one more final breakpoint on the update Arduino function to ensure this breakpoint isn't hit. Yep, this confirms that we have successfully fixed our application. Now, although this fix and debug was relatively simple in nature, it highlights how to use our debugger, step through code, and use its features to troubleshoot and debug more complex applications. Next, let's discuss some best practices and tips for effective debugging. One easy way to restart or end a debugging session is to put the device into DFU mode and then either restart or disconnect the debugging session. Note, if you are disconnecting and want to put the device back into normal mode, then just flash the application firmware. If any odd issues arise while debugging your application, use the Clean Application option, as that typically fixes issues. If the issue still persists, restart the debugging session. If any odd issues arise while debugging your application, use the Clean Application option, as that typically fixes issues. If the issue still persists, restart the debugging session. One tip that I use all the time is to test and verify smaller chunks of code. That way you're focused on certain events, ensuring the device is operating properly as you are developing. In addition to using the debugger, I recommend using the built-in logger class as well to keep track of code execution between breakpoints. And finally, don't be afraid to measure a peripheral signal. Use a logic analyzer or an oscilloscope to identify whether the root cause lies in the hardware or the firmware. Let's quickly recap a couple of key takeaways from today. IoT applications are more complex, requiring more complex approaches to debugging. Particle makes it easy to debug applications using printf debugging using our logger class, along with our integrated toolset and debugger hardware. We reviewed our recommended process flow for getting up and running with the Particle Debugger, walked through a live debugging session highlighting key features and functionality of the debugger, and finally, we reviewed a few tips and tricks that you can leverage while debugging your application. That's it for today. Using Particle's Workbench and our debugger, troubleshooting and debugging your application becomes much simpler. Keep an eye out for more videos and materials showcasing further features and capabilities of our platform. Thanks for watching.